students. We are here today with lesson 5.1, part 4. And really today we're just working on our simplifying. Again, I encourage you to have your trig identities sheet out and able to reference. That's the sheet I shared with you at the beginning of this unit. I also have copied them into the slides, but again, having that sheet out is really helpful just for you to be able to give the problems a try on your own. Remember, I always encourage you to pause the video throughout if you'd like to try a problem before I add the explanation in. Let's go ahead and get started. So again, these are your trig identities that we'll be using. The first column of identities, those are your basic identities. These 8 are ones you've worked with for all of chapter 4, and we're just seeing them again in a kind of a new lens. And then our newest identities are the Pythagorean identities and then the even and odd identities. Today we're going to cover 3 examples of varying difficulty. Here's our first example. It says, use your identities to simplify the expression. So as I've always encouraged you, we are going to begin by taking this and we're going to put it into the top line of our solution process. And we're doing that because that was the problem that was given to us to work with. So my reasoning for putting that in the top is I got to start somewhere. Might as well start with what was given. All right, from here, as I look at this problem, I'm looking for things that I can do to simplify it. And anytime I see a squared term, I instantly think Pythagorean identities. And so as I look through my Pythagorean identity choices, because we're dealing with cosine squared, I automatically think, okay, that top line probably is going to get involved. And so as I look at this, I'm like, well, the way it's written right now, it's not going to match. But if I subtract my cosine squared over, I would have 1 minus cosine squared of x. Awesome. So let's go ahead and do that substitution. So 1 minus cosine squared of x is actually the same thing as saying sine squared of x. Next, I look and I say, okay, can I do any sort of simplifying? And whenever I have the same term over the same term, I can simplify. So a squared term becomes just sine of x. And I'm going to take away one of the sine of x's on the bottom. In this step, I'm just going to give the reason of simplify. And I end up getting a final simplified solution of sine x. This would be what I would call one of your basic solving yet, but a nice one to get us started in moving forward in the process. All right, let's take a look at example 11. Again, my example numbers are just running straight through. It's how I can keep the notes connected. So here is another example. We are going to simplify the expression that I see here. And so again, I just copied and pasted it in. And my reasoning for doing that is because it was given to us. It's what we're told to work with. Now, as I look at this, I am looking for either a substitution or I'm looking for what can I do to change the way it looks. And I notice that I have 2 terms being added together. And those 2 terms have a common factor, and that common factor is sine x. So if I factor out sine of x, this is like a greatest common factor, I am left with sine squared of x plus cosine squared of x. And my reasoning for being able to do that is because I factored out a GCF. Now, hopefully you're starting to recognize I have about a bunch of squared terms here. And as I look at this, I go, well, looky there, it's my Pythagorean identity. So that whole entire highlighted part is going to end up becoming 1. So now I just have sine of x times 1. And the reason I could do that is because sine squared of x plus cosine squared of x equals 1. Last but not least, just multiplying that together, this also simplified to sine of x. Awesome. So a couple things that made me think to factor was I had a cubic and I don't have any of my identities that allow for me to deal with a cubed term. I also saw that I had a squared over here, and so that kind of made me think, oh, maybe factoring would be a good idea. So that's the why I chose to start by factoring. All right, I have one more example for us today. This example I'm going to give you a heads up is a little bit more involved, so just kind of be aware of that. We're going to go ahead and just copy this into my table here. And notice that I have actually included many of our identities here on the side bars, so you will start to see, hey, we're going to start to have to pick and choose more. And so beginning here with my reason, I am going to say it was given to me. That's what they're asking me to start off with. All right, so what do we do? Before I state what I would do, I want to remind you that there are a lot of different approaches to doing these simplifying strategies, and I'm showing you one way, but there might be many ways to approach it. So keep an open mind, and if you do it a different way, but are able to simplify it down, great, use your way. I always want you to connect it to your understanding and your way of processing instead of adopting and adapting to what I am telling you to do. In this particular problem, I see 2 fractions, and so I instantly gravitate towards getting it to being a single fraction. And so to do that, I need to multiply the first fraction by cosine of x over cosine of x, and the second fraction by sine of x over sine of x. What this allows me to do is it allows me to get a common denominator. And with a common denominator, I'm then able to do a lot more. So I'm getting a common denominator. All right. And so on the left-hand side, I know that I will end up with cosine times secant, which for right now, I'm thinking we probably need to write this as its conversion like this. It'll help. So I'm rewriting secant as 1 over cosine in this step. And I know that's 2 things in one, and I've cautioned you against that, but we're going to use up a lot of space on this problem if we're not careful. Sine times sine is sine squared of x. And then I'm going to keep that as cosine of x times sine of x. Now, I'm going to pause for just a second and highlight what I did. So we got the common denominator, and then in that same step, I rewrote this as its reciprocal value. Now, the reason I chose to do that was because now I'm able to do some simplifying here, and this numerator of this part just becomes 1. So now I'm left with 1 minus sine squared of x, all divided by cosine of x times sine of x. So what I did here was I did some simplifying. So I went ahead and I simplified that product of the top and got 1. And then I wrote it as a single fraction. Because I had a common denominator, I could write it as a single fraction. All right, moving on to the next part. I'm feeling like we're going to lose this, and we're going to need it to come back into play here shortly. So I'm going to just drag that down here so we have it more accessible. And we're here. And because we're here and we see that squared, we instantly jump up to this particular line right here. We say, oh, squared. She said squareds are Pythagorean identities a lot of the time. And this isn't matching perfectly, but it is looking a lot like it. So if I subtract the sine squared over, I'm going to be left with cosine squared equals 1 minus sine squared. That's really good. That means I can replace the entire numerator with cosine squared. All right, now as I look at this, I go, oh, sweet. I have a cosine on the top and a cosine on the bottom. I am simplifying this. So that orange writing, that's just another simplify. You see that show up a lot. But hey, friends, we're there. We made it. This last step is simply noting that cotangent is cosine divided by sine. And I'm done. We won. We got to the end and we simplified it. You did a great job on this problem, friends. We're making it through and we're starting to get the hang of trig proofs. So if you have questions, definitely let me know. But I have one more lesson on this tomorrow, just kind of wrapping it up and doing a little bit of solving with these trig identities. So keep checking back for more help. Have a great day.